So I've got a couple of questions here for you relating to 3x3 systems and matrices. What I want you to do is read the questions, pause the video, have a go at them, then come back and check your answer against the working I'm going to present to you. So here you go. So it's just two systems of equations. I want you to use elementary row operations to solve them. Make sure you put them in an augmented matrix first. Remember, that's a big help to us all. So pause the video and have a ping at those. So the first one was these three equations here. I wanted to solve them to find x, y, and z. First thing I'm going to do is put it into an augmented matrix. And again, you can get this just by looking at the coefficients and the solutions associated with each equation. So the top row would be 1, 3, negative 1, negative 4. Second row will give me negative 2, negative 3, 1, 1. Third row would give me 4, negative 1, 1, and 17. So now I have to start to manipulate it, ultimately with the goal of getting it in upper triangular form, if I'm able to. If we end up getting to a point where we can solve it a little bit earlier than that, we just jump in with both feet and go for it. So what I can do is if I take row 2 and I add on 2 of row 1, what's going to happen is this is going to disappear here, because I'm going to have negative 2 plus 2, so that'll go. So I'm going to perform that calculation there. What I'm also going to do is row 3, take away 4 of row 1. Again, same logic, these will disappear, so that means that I've then got a 0 starting on the bottom row. So if I do that, first row remains unchanged, 1, 3, negative 1, negative 4. It's just rows 2 and 3 that will change. So I'm going to add to this, so I've got negative 2 plus 2, which is 0. I've got negative 3 plus 6, which is 3. I've then got 1 plus negative 2, so 1 minus 2 gives me negative 1. And I've then got 1 plus 2 of these, so I've got 1 plus negative 8, so 1 minus negative 8 gives me minus 7. I then look at this next one here, do this, take away 4 of that, so I'll end up with a 0 here. I've then got negative 1, take away 4 of those, so I've got negative 1, take away 12, so I get negative 13. And what I've then got is 1, take away 4 times this negative 1. So I've got 1 minus minus 4, so it's adding them, so I end up getting 5. Then I've got 17, take away 4 times this, so 4 times negative 4 gives me negative 16. I've then got 17 minus minus 16, so 17 plus 16 gives me 33. So there is the next one. What I'm then going to do is, in order to be able to get rid of these two variables here, so somehow get rid of one of these coefficients, I'm going to take row 2 and I'm going to times it by 13, and I'm going to take row 3 and times it by 3, because what's then going to happen is these two numbers will be equal but opposite signs, so I can add the two rows to then eliminate one of them, which will be the one on the bottom. So I can say it's fine, I'm going to have 1, 3, negative 1, negative 4, again top row remains unchanged. I've then got 13 times this row, so I'm going to have 0, 39, negative 13, I've then got negative 7 times 13, so that's negative 91. Never said the numbers would always be fun. I've then got 0, and I'm multiplying this whole bottom row by 3. So that there is going to be negative 39. This here is going to be 5 times that, so I'm going to have 15. Then got 33 times 3, which is going to give me 99. So there you go. So what I can now do, add them. So if I say, right, so row 3 plus row 2, that's now going to go into row 3. So my top row going to remain the same, 1, 3, negative 1, negative 4. Second row here is going to remain the same, so 0, 39, minus 13, minus 91. And then the bottom row is going to be 0. I've then got negative 39 plus 39, so it's going to be 0. I've then got 15 plus negative 13, so take it away, so I get 2. I've then got 99 plus negative 91, so 99 minus 91, that gives me 8. So now that I've got to that form, upper triangular form, remember this whole triangle here is now all zeros, so I can start to read off solutions. So bottom one tells me 2z is equal to 8, so z is equal to 4. The next one here tells me 39y minus 13z, so minus 13 times 4 equals negative 91. So 39y, so 13 times 4 is 52, so minus 52 equals negative 91. So if I then add them, I get 39y, shift this across to here, equals negative 39. So y is equal to negative 1. Then take the top equation. What I'll end up getting is x plus 3y minus 2z equals negative 4. If I take the y and the z across here, while substituting in, what I'll get is that x is equal to negative 4. I've then got minus 3y, so minus 3 times negative 1. This then becomes plus 2z, so it's going to be plus 2 times 4. So I then get x is equal to negative 4. So 3 times negative 1 is minus 3, minus it. So I get plus 3, then plus 8. So I get x is equal to 7. So the solution for x, y, and z satisfies this system of equations is x equals 7, y equals negative 1, z equals 4. So there you go, that satisfies that. Remember, like I said here, when I was doing these row operations, I never said the numbers would always be nice, but they still worked out nicely in the end. Second question I asked you to solve was this one. Now, what I'm going to do before I even start is I'm actually going to swap these two equations in my system of linear equations around. The reason being, the coefficient of the x on this row will then be negative 1, but it will have a size of 1. So what I'm able to do is take that and scale it up to match each of these with a simple multiply 2, multiply 3, and then do a row operation quickly and easily to get rid of it. So I'm going to rewrite the full system of equations as negative x plus y plus 2z equals 11. We've got negative 2x plus y minus z equals 1. And 3x plus 2y equals negative 4. So now put it in an augmented matrix. What I'll end up getting, based on this one, remember, it's negative 1, 1, 2, 11. I'll have negative 2, 1, negative 1, 1. And then my bottom row will give me 3, a 2. Now there'll be a 0 in the z column because I've no z's. And then minus 4. Now that I've got my augmented matrix, I begin my row operations. So if I do row 2, take away 2 row 1, this will become a 0. And if I then do row 3 plus 3 row 1s, that will become a 0 again as well. So that's the first row operation I do. So that's going to give me, top row stays the same, so negative 1, 1, 2, 11. Second row is I take it and I subtract 2 of these ones. So negative 2 take away minus 2, that's going to be a 0. I've then got 1 take away 2, which is negative 1. Then got negative 1 take away 4, so I get negative 5. I then get 1 take away 22, which gives me negative 21. Bottom row, I'm going to add 3 in the top rows, so I'll end up getting 0 there. I then get 2 plus 3, which gives me 5. I then get 0 plus 6, which gives me 6. And negative 4 plus 3 of those, so that's 33. So negative 4 plus 33 gives me 29. So there you go. Now one thing I'll notice is ideally I want to turn this into a 0. Well, if I were to do row 3 plus 5 of row 2, what would happen is I'd get my 0 here by manipulating these two. So that is the next row operation I'm going to do. Top row would stay the same, -1, 1, 2, 11. Middle row would stay the same, 0, -1, -5, -21. The bottom row would change though, because I get a 0. I'd get 0 here because I'm adding 5 of these. I'd then have 6 plus 5 of these, so I'd have 6 plus -25. So 6 minus 25 would give me -19. I've then got 29 plus 5 of these, so -29 plus 5 of the 21, so 5 21s is 105, so I've got 29, take away 105, which would give me a solution of -76 here. And now that I've got it in that upper triangular form, I can start to read off the lines. So using row 3, what I can tell you is that -19z is equal to -76. So from that, I can tell you that z is equal to 4. Second row, row 2, what that tells me is -y, take away 5 times z, so 5 times 4, is equal to -21. So -y minus 20 is equal to -21. So if I add this on, what I'll end up getting is -y is -1. So y is equal to 1. And then row 1, very top row, that gives me -x. I've then got plus y, so plus 1. I've then got plus 2z's, so plus 2 times 4, plus 8 equals 11. So -x plus 9 equals 11. -x is equal to 11 minus 9 is equal to 2. So -x is 2, x is -2. So my solution for this system of equations is x is -2, y is 1, z is 4. So that there satisfies all three of those linear equations, and that's me got my three variables x, y and z, and I've solved it. Now again, the numbers may not be 100% straightforward, but you know, they're not difficult to work with. You know, your -19 and -76, you know, dividing them through to get 4. It's fairly straightforward. The numbers just look bigger than you really hope. You know, ideal scenario is that you would get 4z equals 16. But this is what we may end up with. But it is still much more straightforward and simpler than rearranging each of those to get y as a subject of a formula, z as a subject of a formula, and x as a subject of a formula, and plugging in the other variables for it. It just opens up so many avenues when it comes to looking at sets of equations and systems of equations when we start to put in 3 or 4 or more variables. We just have to remember how to do these, how to manipulate them, and how to work with them so that we can apply it further out and in a wider field of things that we're going to be looking at.